My dear students, welcome to this series of programs on mathematics for grade 12. Today we are going to look at trigonometry, the double angle formula. Now, let A be an angle 30 degrees. Then double angle A will automatically be equal to 60 degrees. So if A is 30, double angle A will be 60. If A is 10, double angle A will be equal to 20. Now, what are we going to learn? What are the double angle formulae? Sine of double angle is equal to how much? Very often, the common mistake is to say it is equal to 2 sine A. Remember, this 2 is an angle, whereas this one is a coefficient. This is wrong. In fact, sine of 2A becomes 2 sine A cos A. I would like you to verify it at home. Take your calculator, calculate sine 60. Calculate sine 60. Then, note the answer, which gives you root 3 over 2. Then, calculate 2 sine 30 times cos 30 separately. And you will find that you will get root 3 over 2. Okay? So, sine 2A is 2 sine A cos A. You will have to remember this formula. Then cos of 2A is cos squared A minus sine squared A. Not to be confused with the trigonometric identity, which is cos squared plus sine squared equal to 1. Here, cos 2A is cos squared A minus sine squared A. In fact, there are 3 ways that we can write cos 2A. 2 cos squared A minus 1 cos 2A, say 1 minus 2 sine squared A. So you have 3. Just as above, take your time, do verify. If I replace A by 30, so cos 30, I calculate cos 30 squared, and then I calculate sine 30 I squared, I subtract. The answer that I will get will be exactly the same as cos of 60 degrees. You can verify that at home. Tan 2A is 2 tan A over 1 minus tan squared A. So, what does this mean? Tan of 60 degrees. Tan of 60 degrees is equal to 2 times tan of 30 degrees divided by 1 minus tan of 30 degrees to the squared. So, I have 1, 2, 3, 4, 5 formulae that I have written for you. Cos of 60 is equal to cos of 30 to the squared times 2 minus 1. So, these are the double angle formula that you must remember. Not to make mistake, I repeat it here. The identity is cos squared plus sine squared equal to 1. Here, in the double angle formula, we have minus. So we'll take an example. If I ask you to solve cosec 2 theta minus equal to sec theta plus tan theta for all angles between 0 and 360 degrees. Just correct that. So, solve cosec 2 theta is equal to sec theta plus cot theta. Find all angles that satisfy this equation between 0 and 360 degrees. Of course, you will tell me, well, I know this is double angle, this is single angle, this is single angle, but we have never written any formula for cosec 2 theta. We have written for sine, we have written for cos, we have written for tan, but not for cosec. So what do you think we will do? What is cosec 2 theta? It is 1 over sine 2 theta. What is sec theta? 1 over cos theta. What is cot theta? Cos theta over sine theta. Now, I will use the double angle formula that we have just learned. What will be sine 2 theta? Sine 2 theta will be equal to 2 sine theta cos theta. 2 sine theta cos theta. Here as well, we can have the common denominator, cos theta sine theta. So up we'll have sine theta cos squared theta. So I repeat it, I didn't show you how to write the formula for cosec 2 theta, but we have learned only for sine 2 theta, and this is what we have decided to use here. Let's simplify. When we simplify, what do we get? We get 1 equal to 2 sine theta plus 2 cos squared theta. Of course, I've sent the 2 on the right-hand side. Now, I have an equation here that contains sine and cos. We would like to have an equation in only one trigonometric function. That's why I will decide to either replace sine theta or cos squared. Can you tell me which one would be easier? Sine theta or cos squared theta? Of course, cos squared theta. So what are we going to do? We are going to replace in terms of sine. How? By using the formula cos squared equal to 1. Means cos squared theta is equal to 1 minus sine squared theta. So I have 1 equal to 2 sine theta. Here it becomes 2, 1 minus sine squared theta. So I obtain a quadratic equation in sine theta. 2 sine theta plus 2 minus 2 sine squared theta. And we are going to solve this quadratic equation in sine theta. So remember, the question was to solve cosec 2 theta equal to sec theta plus cot theta. We didn't have a formula for cosec 2 theta explicitly. We decided to write cosec as 1 over sine 2 theta. Sine 2 theta, we decided to write sine 2 theta as 2 sine theta cos theta. Right? And then we had the common denominator. We simplified to obtain 1 equal to 2 sine theta plus 2 cos squared theta. We cannot solve an equation like that directly, so we either have to write this sign in terms of cos or the cos squared in terms of sine. Which is easier? Writing the cos squared in terms of sine. So we decided to replace cos squared by 1 minus sine squared, and we simplified. We will now solve this quadratic equation. So now we'll transfer all the terms on the left-hand side. This gives us minus 2 sine squared theta becomes 2 sine squared theta, minus 2 sine theta. 1 minus 2 becomes minus 1 equal to 0. So I have to solve a quadratic equation in sine. We can say let sine theta equal to s. So this gives us 2s squared minus 2s minus 1 equal to 0. So if you apply the quadratic formula, a is equal to 2, b is equal to minus 2, c is equal to minus 1, s equal to 2 plus minus b squared minus 4ac divided by 2a. So this becomes 2 plus minus 4 plus 8 divided by 4. So this gives us 2 12 square root of 3 times 4 divided by 4, so 2 plus minus 2 square root of 3 divided by 4. So the answer is 1 plus minus root 3 divided by 2. So s is equal to either 1 plus root 3 divided by 2, or s is equal to 1 minus root 3 divided by 2. So sine theta, I replace s back by sine theta equal to 1 plus root 3 divided by 2. As you know, sine would take a value between minus 1 and 1. So, in that case, this value would be greater than 1. So, we say that the theta doesn't exist here. In this case, theta is sine inverse 1 minus root 3 over 2. We calculate the value in the first quadrant. Since sine is negative, we are not going to take the value in the first quadrant. If you calculate the values in the other quadrant, you will get 201.5 and 308.5. Remember what we have used. We calculated the value in the first quadrant. Its relative in the second quadrant is 180 minus theta. Third quadrant, 180 plus theta. 360 minus theta. So this is the answer. Theta is 201.5, 308.5. So this is an example where we have used the double angle formula to solve an equation. We are going to take another example on proof, which according to me is one of the most difficult proofs on double angle that Cambridge has ever asked. Okay, so we are asked to prove cos 4 theta minus 4 cos 2 theta is equal to 8 sine power 4 theta minus 3. Remember, we have never shown to you how to simplify cos 4 theta. We have just seen the double angle formula. So we start with the right hand side because we know sine theta. 8 sine power 4 theta minus 3. Now, sine power 4 is sine squared theta to the squared minus 3. And why I wrote it in terms of sine squared? Because I knew the double angle formula, which says that cos of 2a is 1 minus 2 sine squared a. So if I want to make sine squared subject of formula, this gives me, I transfer it to the left hand side, 2 sine squared a, 1 minus cos 2a, divided by 2, sine squared a is half minus half cos 2a. So, sine squared theta will become half minus half cos 2 theta. So if we replace that here, it will become 8 1 minus cos 2 theta over 2 to the squared minus 3. So, if we simplify that, this becomes 8, 1 minus 2 cos 2 theta plus cos squared 2 theta divided by 4 minus 3. So we can simplify that, this becomes 2. So this is equal to 2, 1 minus 2 cos 2 theta plus cos squared 2 theta minus 3. Now, once again, I see cos 2 theta, cos squared 2 theta. So I decide to use my double angle formula, cos 2a is equal to 2 cos squared a minus 1. This time, I'm going to replace a by theta, a by 2 theta, so that 2a will become 4 theta. So the double angle formula becomes cos 4 theta is equal to 2 cos squared 2 theta minus 1. If we make cos squared 2 theta subject of formula, this will give us 2 cos squared 2 theta is equal to cos 4 theta plus 1 divided by 2 cos squared 2 theta is equal to half cos 4 theta plus half. So I'm going to now replace, we had 2 here, 1 minus 2 cos 2 theta. The cos squared 2 theta will now be replaced by half cos 4 theta plus half minus 3. Let's simplify, multiply by 2, all the terms by 2. So this will become 2 minus 4 cos 2 theta plus cos 4 theta plus 1 minus 3. So I have cos 4 theta, I have cos 4 theta here, minus 4 cos 2 theta here 1 minus 3 is minus 2, minus 2 plus 2 is 0, which is the left hand side, hence proved. So, this question had cos 4 theta. We have not learned about cos 4 theta. We have learned about cos 2 theta. But the question was to prove that cos 4 theta minus 4 cos 2 theta is equal to 8 sine power 4 theta minus 3. So we started with the right hand side. We decided to write power 4 as power 2, power 2. So sine power 4 theta becomes sine squared theta to the squared. Now the sine squared I decided to replace in terms of cos 2 theta. So I remembered that cos 2 theta is 1 minus 2 sine squared theta, and we made sine squared subject of formula. It became half minus half cos 2 theta. So I had 8. This one was replaced by 1 minus 1 cos 2 theta divided by 2 to the square. So we squared the numerator. It becomes 1 minus 2 cos 2 theta plus cos squared 2 theta. The 2 to the square becomes 4, which is eliminated here. We are left with 2. So when we reach this stage, we realize that we have another cos squared 2 theta. So we decided to use double angle formula once again, but this time a different double angle formula for cos. Cos 2a is 2 cos squared a minus 1. If we replace a by 2 theta, 2a becomes 4 theta. So I replace a by 2 theta, the 2a will be replaced by 4 theta. I make 2 cos squared 2 theta subject of formula, so I have cos 4 theta plus 1. Divide by 2, half cos 4 theta plus 1. So I'm going to replace the cos squared 2 theta that we had here by half cos 4 theta plus half that we got. Minus 3, and then we simplify to get the left hand side. So hence we have proved this trigonometric identity. So my dear students, here in this lesson we have shown what are the double angle formulas for the trigonometry chapter in your syllabus, your A-level HSC syllabus. We have also illustrated how you can use the double angle formula to solve an equation, a trigonometric equation, as well as to prove a trigonometric identity. Hope you have enjoyed this session with us. Until next time, it's goodbye from us.